Good morning, everybody, and welcome to another edition of Aquarium Online Academy. My name is Amanda, and I'm coming to you live from the Aquarium of the Pacific in Long Beach, California. And we are excited. We have some really cool things to be looking at behind me right now. And the way that we're able to do that is because I have my friend Allie, who's controlling all the things that you'll be seeing on the screen behind me. And then my friend Carrie is going to be sitting at the computer and ready to respond to anything that you would like to contribute to this class today. So I would like to invite any teachers that are out there. If you have a school group that's watching today with us, I would love for you to text in and let us know how many are in your group. So we have an idea of how many people we're reaching with these programs today. That helps us out a lot. And you can text any questions that you have during the program and text those answers into 562-286-1838, the number you see on your screen now. And if you have any questions, if you're watching this at a later time, you're welcome to email us any questions you have at live@lbaop.org, because we would love for you to be able to participate along with us. And even if we're not doing it live at the time you're watching, you can still have a way of interacting with us, and we'll get back to you and answer those emails. So as we are going to be exploring today, we're going to be looking not just at these types of beautiful animals behind us, but we're going to be understanding a little bit more about how the bigger picture of what these animals need to survive, how things are affecting their environment, and how we might be impacting the environment and the place where we live, the place we call home. So here we have one particular exhibit. This is our shark lagoon habitat, and you might notice the coral reef behind or in the exhibit, and all the sharks that are relying on that coral reef habitat for home. But the coral reef is just one part of an ocean habitat, and the ocean overall is very, very large, and it covers a lot of our planet. So we are going to be looking at our planet, and we're going to be discovering the Earth together today. And the way we're going to be discovering the Earth is by using a special tool that we call SOS Explorer, and it's something you can actually check out at home on your own. You can check it out on your computer. You can get an app and put it on your phone or an iPad and learn more about the Earth that way. So we'll be exploring together using that app, but I'd also like you to just tell me some things that you know already about how are the Earth and the sea connected to each other, because our planet is made up of Earth, of land, and water. And so I want you to be thinking about, how do those things interact with each other? Where do they interact with each other? So if you have any thoughts, go ahead and text us those thoughts, and my friend Carrie will relay that information to me. But think about how the land and sea connect with each other. Do things on land affect the ocean, or do things in the ocean affect the land? And how might they do that? And we'll see if we can explore a little bit together. But let's see where we're going to start off with. I'd love to wait to hear from you to see what kinds of things you're thinking about, how the ocean affects the land, how the land affects the ocean, so that we can tie in these ideas together as we look at the planet that we live on. So as you're thinking about it, I'm going to step off the screen, and I'm going to grab my SOS Explorer, and I'm going to let you just take a look at this right now. So here we have a picture of our Earth. What are some things you notice about the Earth, just in this picture right here? Well, maybe I should ask you, is this an image of Earth right now? Is it spinning in outer space? Or is this something else? How would we get this image? And what is it that we're looking at? How would we know if this is a picture of Earth right now at this very moment? Are there any clues that you have as you look at this? Anything you're noticing or not noticing to tell you whether this is an actual image right now of the Earth? Well, do you see any movement? I'm not seeing a whole lot of movement on it. What if we maybe change some things? Let's look at, let's look at it in a different way. What are some things you're noticing now? What do you see as you look at this? It looks a little bit different than what the image we had in front of us just a moment ago. How is it different? And what are you noticing? And does it give any more ideas as to how the earth and the sea might affect each other? Well, I'm noticing colors. As I see this, some colors are obvious to me. They stand out. We've got the blue and we've got the green. We also have some kind of brownish colors, but then we also have white. Now, what do those different colors mean? All the images that we're looking at are giving us data or information, and we can look at it in different ways. And color is a type of information we're getting, and our brain is going to tell us that those different colors mean different things. Now, we're used to seeing a picture of the earth. We know that the blue is going to represent the water, the green land, but then what again is this white? Because there can be lots of things that are white. But I'm noticing some movement here. And what do you think that movement might be telling us? So think about it for a second. Is there anything in particular you notice about this movement right there? What could that be? And why are we looking at it right now? I'll give you a second. I'll step off the screen. Okay, we're getting some observations coming in.
Things on land like pollution and habitat loss can affect the ocean, and things in the ocean, sea level rise and ocean warming can affect the land because the earth is connected.
Oh, wow. So we're getting some really great feedback from you. People are talking about how pollution on land can affect the ocean. We were talking about sea surface or the rise of the water sea level rise. That's what I'm trying to say. Sea level rise. You were talking about how that is something that we've been doing that is impacting the ocean. And if that's happening in the ocean, that's going to be affecting us on land too. Also, ocean acidification. Those are all different things that definitely play a role. But what about this right here? What does this have to do with anything? These white things that you're seeing, what do you think they are? I'm sure you're thinking it. They're clouds. So what do we know about cloud movement? Do you see any patterns for how these clouds are moving across our planet and where you're noticing them? Okay, and I saw my friend Allie was going like this. She was seeing that the clouds are spinning in circles. I wonder what that means. And there's this big spot right there in the middle of that cloud. That's when you see a cloud that's spinning around like this and it has a big circle in the middle, that is a very specific weather phenomenon happening. Do you know what it is? If you're saying hurricane, you're absolutely right. So we're actually able to see hurricanes by looking at how the clouds are moving. And we see clouds moving not just in these little circles here, and there's like a circle up there, but do you see any other spots where the clouds are? And what types of directions are they moving? Do you see any patterns that the clouds tend to be moving in certain ways? Well, let's see. If we look up here, it definitely looks like things are moving in this direction. It looks like they're coming from down here and moving this way. Do you notice any other directions that clouds are moving? Well, we definitely see that as things are moving in the ocean, they seem to be coming from this direction and moving up here, and then kind of going this way. Now, why is it that clouds might be taking different paths? They seem to have some sort of regularity as to how they're moving. And what does that have to do with the ocean? All right, I see that there's a few other comments that are coming in. I'm going to let you keep looking at that a little bit longer.
How can devices capture photos like this?
Oh, and someone was asking, how can devices capture photos like this? That, my friends, is an excellent question. And we are now looking at this as if we are out in space. So if you were out in space looking down, if you were a star and you were looking down at the Earth, this is what you might see if you had a really good, lens that could zoom in. But what other things are out in space that might be able to give us images? If you're thinking of satellites, you're correct. So we have satellites that are out in space that are looking down, and depending on the type of lens that they're using, it's like they have a different type of eyeball for the different things that they're looking for. And this particular image, when we're able to see these clouds moving, well, if it's during the day, it's no problem. We can take like a regular camera and just see these images. You can see the clouds moving. But if it was nighttime, would we be able to see the clouds? Would we be able to see these colors of the Earth? No, not in a regular way, like with your regular camera on your iPhone, but we can see it by using infrared. So there are some satellites that are out in space that are looking through a special heat sensing lens, you could say. And because the clouds are lighter in color, we can even see the clouds at night because their color is, or I'm sorry, their temperature, they're lighter in temperature. We can see those. So right here, we're looking at, we actually don't know exactly what if this is day or night because nothing's changing. If we were looking at the Earth during daytime and nighttime, we would expect that it would look different. But there is a little bit of information up here that you might be able to see, and it has a year and a date, and it also has a time. So you'll notice that this time is moving pretty quickly, and we're not seeing the light and day. So this is not from a regular camera. This is infrared, where we're able to get this from a satellite out in space that's in one spot above the Earth, looking down at that same spot all the time. It's not rotating around, but it's actually just staying in that one spot, giving us this image. So there's different types of satellites that are out in space. And let me see if we happen to have something that would show you those satellites. And let's look at this. Now this is really fun because this is something I have not seen before, and I'm not sure how well it's going to come across on your screen. I know that these letters are kind of small, but you might be able to get the idea that there, where all these little yellow words are moving, these are representing different satellites out in space. And they're looking, some of them you'll notice are moving around the Earth. These are really close to the Earth, and they might be rotating as the Earth is rotating, staying in that one spot. And then there might be other ones that are just pretty much staying, you know, in one location as the Earth is moving. And so these are different satellites that are giving us all sorts of different information about our world. So that is how we're able to get these types of images. And and also if you look at the date that's on here on the timestamp, right up here, right up here, it looks like this is today. So this is what's going on right now. This is some real-time information about satellites that are out in space. All right, well, let's take a look at what the Earth would look like if it was nighttime. What would you expect to see at night if you were looking at the Earth from outer space? So here you'll notice we don't see those clouds so much, but we do see something. What is it that we're seeing here? And what part of the world are we looking at? Can you tell? I'm going to kind of rotate it around a little bit. And if you think you see where we live, let me know. I'm going to stop it right there. Maybe zoom in a little bit. Does that shape look at all familiar to you? I realize it's a little bit blurry, but I can kind of see the outline of the United States right here. Do you see it? So California would be down here. Texas, we have Florida sticking down, and then the East Coast. And so how are we able to see the shape of our country at night if we're looking down at the Earth at nighttime? What is all this stuff right here? Well, if you're thinking about it, hopefully you're thinking those are lights. And so we can see lights from where people are living. So we're going to notice lights where there are cities, where lights are coming up from Earth. That can be seen out in space. And then there's also areas where it's a little bit darker. Maybe there aren't as many people living there. And then again, California, we know there's lots of people here. More lights over here. So we can actually learn about the Earth even looking at it at night. If we take away those clouds and we can just see where the lights are, there are lights that are coming up from Earth that are telling us where people live. And we're able to kind of see the outline because it is very common for people to live near the coast. And why might they want to live near the coast? Well, think about all the wonderful things we enjoy when we think about going to the beach, going to the ocean. There's recreation, there's fun swimming, you can go fishing, you can do snorkeling, you can go water skiing, you can just simply enjoy the view. And so the Earth or the ocean is also important for us for things that we need from day to day. In fact, some of the clothes that you might be wearing probably use the ocean to help get to you. They may have come from across the way. You may think about how you communicate with people. And a lot of things happen through things having to do with the ocean and exporting and importing things and how things travel. So the ocean is important in our day-to-day lives in ways that maybe you weren't thinking about before, and certainly in ways that we can enjoy. But again, how are these two things affecting land and the ocean? You mentioned the pollution that could go out to the ocean from land. Well, how about how the ocean itself is affecting land? Can you think of any ways that the ocean might affect land? I'll go back to a different set that we can look at here. Oops. So looking at we looked at the clouds. We've looked at where land is. We've looked at how much ocean there is. Are you actually kind of surprised? If I move it right here, look at all this blue that you're seeing. There is a lot of ocean there. So I think that the ocean must have some sort of impact on the Earth, but can you think of any ways that it has? In fact, I'm going to have, if maybe we can go to a screen, one of our exhibits for a moment, or a kelp forest or something like that, so we can maybe pull this off our screen for a second. So now look at this kelp forest here. In what ways might a kelp forest affect us on land? Can you think of any ways? And what do you notice about this kelp forest and how this kelp is moving? Think about the water itself. How does water move? And what might affect how the water moves? And as the water is moving, how does that affect us? Think about going to the beach. When you go to the beach and you find that border where the land and the ocean connect, what do you see? What is it like? Is it just one straight line that's right there and you can just suddenly just step into the water and then you cross back over a line and you're completely dry? What is it like at that border where the ocean and land connect? Have you ever noticed waves? Where did those waves come from? What is the force behind those waves? Any ideas? There are different kinds of waves too. Sometimes they're just at the surface, but some waves are much, much deeper and they can travel very, very long distances. Well, we saw that as the clouds were moving, they seemed to follow a pattern. Do you think the ocean follows a pattern as well? Could the waves follow a pattern? What kinds of things are you thinking of now? How does the ocean move? Because as the ocean moves, that actually affects some of the weather that we're having. And some of those clouds that we were seeing, those are impacted by the ocean and how it's moving as well. Think about it for a second and let me know any observations that you have, any thoughts that you'd like to share about how water moves through the ocean and how it impacts the land. Have you thought of anything? Okay, well, we have someone who is asking, do people, let's see, so as you're looking at the kelp, another way that we might be impacted by the ocean are the things that we do with the things in the ocean that we find, like weaving with kelp. And honestly, there probably we've found a use for everything in the ocean pretty much. And there are probably people who have done weaving. I do not personally know of any particular types of crafts and things that have been made with it, but I know that there are many people who use a lot of the natural resources of the ocean, probably long before we had any technology and were able to create things, and before we had sewing machines and things like that, that they were able to use those ocean resources to come up with things to ways that they can use them for baskets or making things. So I'm sure that people do weave with kelp. I imagine, though, that it probably gets pretty smelly. I don't know if you've ever been to the beach and you've noticed this kelp washed up on the beach before. Sometimes there's flies around it. It can get kind of smelly, and it does dry out. But it is pretty fascinating to watch and look at the type of habitat that it supports when it is in the ocean. So these sea lions here are enjoying the kelp forest, swimming around it. There are many animals that rely on it for kelp. We use kelp every day. If you enjoy ice cream, that's one of those things that has a lot of kelp in it too. So we definitely get products from the ocean in addition to just like the fish you might eat if you're a seafood eater, or any other animals that come from the ocean, other seaweed from the ocean. So we do consume it as well. But there are other uses that people find for it. So I want to get back to the fact that waves move around the ocean. We have things, there are waves that you can see right here. A lot of ocean movement right here at the top. Some of this is because as those waves are coming in, it might be creating certain surges where there's a lot more movement, like you see right here. This is what we call our surge channel. It's when that water is coming into an inlet and creating these big, rough, hazardous sort of environments for the water. We wouldn't want to be in it, but these animals can survive just fine with it. And so it can be really, really rough and, very hazardous environment, like I said, for people, not so much for the animals. But then it goes out. So what is it that's causing those waves to come in and out? Well, you've probably heard about the tides. You know that the tide can rise, the tide can fall. When you go to the beach, if you stand on one spot, sometimes the ocean's coming up over you, sometimes it's not, and it's going back. And a lot of those waves that we experience have to do with the wind, and the stronger the wind, the higher the waves are going to be. But there are also other things that drive waves. Can you think of any other significant waves or what may have caused them? Where do waves come from? And can you remember any time maybe in history that you can think of that people have been concerned about ocean waves being bigger than normal? And why might that be? What might cause a really big ocean wave to happen? Can you think of any impacts on the earth that might cause that? So think about that for a second. I'm trying to pull up a data set that we could look at. Okay. Well, hopefully you've remembered that some big waves are not caused by the wind, but they're actually caused by other impactful events, such as, say an earthquake. Now, what I'm doing here, I'm going to pause this for a second, because back in 2011, there was a very significant earthquake that hit Japan. And as a result of that earthquake, it caused something known as a tsunami. And the tsunami waves traveled pretty far across the ocean, and they impact. Tsunami waves travel really, really deep. It's not just up at the surface like the wind, as the wind is pushing waves, but it can move everything through the ocean and really even affect the bottom of the ocean as a tsunami wave travels. But it travels far and it travels fast. But I want you to look at this right here, because these red and blue lines that we're seeing are marking where the tsunami waves are, where the highest part of the wave is and where the lowest part of the wave is, because as the waves look like this, you're looking at the highs in the reds and the lows in the blues. And I want you to look at where it's coming from. So Japan is over here. And all of these yellow boxes that you see are really important for letting us know when tsunamis are happening. And I want you to think about what those yellow boxes might represent and where they're located. What might those things be? Notice they seem to be in the water. So what might be in the water that's giving us information about what's going on in the water? Well, after that tsunami, or after that earthquake happened, it sent out this tsunami. And I want you to notice how that tsunami is traveling. Where is it going? And how far is it going? Can you tell what part we're looking at here? This is the Pacific Ocean. And if I move it around, you can see, here's the United States over here. Here's where California is, and there's more of these little yellow squares. And then what do you think this is right here? Hawaii! So here's Hawaii in the middle, and then we've got over here, Japan, where the earthquake happened, right up here. Now, how far do you think the tsunami wave traveled? Do you think it traveled all the way over to Hawaii? Could it reach that far? Do you think it traveled all the way over to California? Do you think the tsunami hit California? Okay, what about South America down here? Do you think that tsunami could have traveled all the way down here? All right, let me ask one more question. What about Africa? Do you think the tsunami impacted Africa at all? Could that wave have gotten all the way over here? Why or why not? What are you thinking? If you say, yes, I think that tsunami traveled all the way over here, why? Why do you think it could travel that way? Now, maybe you're thinking, no, I don't think so. There's no chance that tsunami could have gotten all the way over to Africa. If you're thinking that, why? Why do you think that it could travel that far? I mean, after all, we do have different oceans in the world, right? On one side of our continent, one side of the U.S., we have the Pacific Ocean. On the other side, we have the Atlantic Ocean. Are they connected? Well, let's watch and see what happens as the tsunami moves on. Oh, it looks like it's hitting Hawaii. Oh, it looks like it even hit the west coast of the United States and all of North America. And oh my goodness, even down to South America. Oh, but wait, what's this down here? Do you see this happening? Oh, the tsunami actually traveled over to the other side. And looks like even, it's hard to see on here, but there are actually very, very faint waves that show that it traveled all the way over to Africa over here because of that little space right here between South America and Antarctica. So we'll watch this again. We'll see as that tsunami comes, it travels, it hits here, and then it continues on in. So believe it or not, even though it's very faint to see, you probably can't see it on here, but there are red and blue lines traveling all the way to the west coast of Africa. And even, again, it's very faint, but they were traveling around this direction as well. So that tsunami was able to hit the entire world. Now, by the time that tsunami hit us here in California, we didn't have to evacuate the aquarium or anything like that. In fact, we had some people who went out with a video camera and with a regular camera and took pictures of the tsunami. And instead of having to evacuate, by the time it traveled all the way across the Pacific Ocean, it had lost some of that energy and wasn't quite as impactful. And we saw a rise and fall of, what you would normally see between a high and a low tide, except instead of being the course over the course of several hours, it was like a couple minutes. And so we could see the rise and the fall in our harbor right outside the aquarium as that tsunami traveled all that distance across the Pacific Ocean and reached us. And it happened as fast as a jet plane could fly. To get from one end of the ocean over to the other, it traveled about as fast as it would take you if you got in a plane and went from Japan to California, which is pretty amazing. But I hope that you can see here that the ocean can actually affect all of the world, that it's all connected. It's not just a bunch of separate oceans completely blocked by land, but instead there are pathways that the ocean water travels around the entire world. And so what happens in one part of the ocean can affect what's happening in the other part of the ocean. And we're noticing that even occurs with climate change and with how things are affecting how what we're doing is affecting the earth on a global scale, not just in one location, but as the winds move things and as the ocean currents help move the things in the atmosphere. What I want to talk or show you real quick before we end is a bunch of particles. If you were to put a bunch of particles that were all over the ocean and let them kind of sit there, this model shows you where things start to end up. Because as the ocean currents are moving, it's starting to carry things into different locations. And so this is how maybe you've heard of an ocean garbage patch before. It's basically a collection of all these little microplastics and small things in the ocean that you might not see with your regular human eye. And as they're in the ocean, though, as the ocean currents are taking them, they start to get caught up in these little circles, these little places where they can't get out of, where the currents are too strong. And so these particles start to collect. And this is true of any sort of chemical that you're going to find in the ocean. Anything that might come from land and make its way into the ocean cannot just affect just maybe that one beach where it comes out or right where it entered the ocean, but it can travel all around the entire world. So this can kind of highlight some areas where the ocean currents are carrying different things. And I want to show you one important data set that will show how things are moving with sea surface. Here we go. This is the easiest one to see. And again, I encourage you to check this out at home and look at how the Earth and our planet are connected with this SOS Explorer. But if you look here, we can see how the ocean currents are moving. But you'll also notice the temperature. Obviously, we don't have rainbow colored water, but these rainbow colors are representing different temperatures at the surface of the water. And as you see, it's really warm down here in the Gulf of Mexico, and then it starts to come up and warm up along the East Coast. And if you remember, when we were looking at those hurricanes, those winds that were swirling, we were seeing them come from this direction and then move this way. And they're actually following currents, warm water currents that are coming from the equator that are traveling up along the coast up here. And then they get cooled off as they get up to the poles and get the cooler water. And so you'll notice that temperature here is, more of that green range. It's not quite as warm as it is down here. And again, in the summertime, if you look at what the date is showing you, we can actually see the seasonal changes in the water temperature at the surface of the water. But in California, it looks a little bit different. It's not getting really, really red here like we see on the East Coast because our ocean currents are coming from up here. So we are getting the cold water coming down from Alaska that comes down along the California current here. And then it gets moved this direction, and then maybe up to Hawaii where they get that really warm water from along the equator. So the ocean is a system. It is carrying warm water, and it's helping carry the atmosphere with it. The atmosphere and the ocean work together to create the weather patterns that we have, and the things that we're doing on land are affecting how things are going in the ocean. It's going to affect how the animals living in there are doing. It's going to affect, even as ocean temperature changes, that might in turn affect how our weather is like, what our climate is like over a long, big scale as things move around the entire globe, around the entire world. There is no end to how things are connected. So what happens over here eventually will affect us on the other side of the world as well. So as things get warm in an area, they might get cooler somewhere else, or it might cause them to get warmer too. So I want you to be thinking about the Earth as a big scale. Oceans connected to the land, the currents are connected to the atmosphere, and we're all needing to do whatever we can to help take care of it and keep ourselves healthy as well, because many of the things that we might need for our survival come from the ocean. And so let's just remember that big connection there. And I hope you all have a wonderful day. Thanks for joining us today, and enjoy the rest of your week. Bye, everyone.